In this first video on forging hardware, I'm going to discuss how to make three simple types of hooks. The drive-in hook, which comes with its own mounting hardware. The standard wall hook that gets mounted with screws. And finally, a small decorative hook. The drive-in hook is probably the oldest form of hook. It's a purely functional hook. It has a nail built right into it so you can drive it right into a log or heavy plank. I start the hook by forging out the nail. I'm using 3/8 round bar, and I usually work off of a 2 or 3 foot length of a bar. I just estimate the lengths as I go, and I found that the people who are interested in this type of hook are usually more accepting of the variations that come from working this way. If you prefer to work with pre-cut lengths, then I would use a 6 or maybe 7-inch piece of 3/8 round bar to make the size of hook that I'm making here. Once the nail is made, it needs to be bent into position. I usually do this by holding the bar in a heavy pair of flat bit tongs with the shoulder of the offset facing up. I use tongs here for two reasons. One, it's faster than going over to a vise and cranking it open and closed, and the vise also sucks a lot of heat out of a small piece like this. So using tongs allows me to complete the bend while the metal is hot. For this heat, I'm going to be shaping the upper part of the hook as well as refining that square corner where the shaft of the hook meets the nail. The square shoulder really makes driving the hook in place a lot easier. This square shoulder would allow you to strike the hook directly over top of the nail, but the rounded corner would force you to hit off to the side, making it harder to drive the hook in straight. When you're forging this corner, it's important to strike a balance between aesthetics and function. You need to have enough material in the corner for the hook to work, but I don't believe in this application that it's worth an extra heat or two to make sure that you have a truly sharp square corner that you would put on a decorative piece. The location of the heat on the bar is an important thing to consider when you're doing production work. For example, here I'm forging the hook from start to finish, so I tried to keep the heat on the hook side of the bar rather than on the stock side. If I was returning the stock to the fire so that I could start the next hook, I'd move the heat further down the bar so that that part of the bar would be easier to reheat. When I do demonstrations to the public, I will forge the hook from start to finish so that they see the whole process. However, in my own shop, I find it easier to forge the hooks in stages. It's really a matter of personal preference. I just find that I work more consistently and more accurately if I repeat the same process over and over again. Also, I try to keep the amount of tool shuffling that I do to a minimum. Setting up different tools for each part of the process really takes its toll when you have several hundred of a certain piece to make. A small curl at the tip of the hook gets forged facing the nail side of the hook. I'm placing my hammer on the tip just to cool it slightly so I can begin forging the rest of the hook. If I left this tip hot, it would deform as I was hammering it around the horn. And again, this is more economy of motion. I just find it easier and more accurate to do it this way than bending over and putting it into a bucket of water. This is a standard design for a wall hook. It's an easy hook to make, but it still has a nice forged quality to it. Once again, I start by shaping the top end of the hook. However, for this hook, I do use pre-cut pieces of bar stock. The hook I'm working on here is made with a 6-inch length of 3/8 round bar. I'm using pre-cut lengths because I want to keep the size of this hook very consistent. I'll often have people coming back to buy more of these hooks, and they usually want them to be the same size as the ones they already have. I'm using the very last bit of the heat here to locate the holes for the screws. In the next heat, I'll be creating the seats for the screws using a punch that I have ground to the exact angle of the screw head. I won't be punching the hole all the way through. I'm just going to be using this punch to create a flared depression to seat the screw head, and then I'll be drilling the material out later when it's cold. This process combines the look of a punched hole with the accuracy of a drilled hole. In this heat, I usually try to complete the shaping of the middle portion of the hook as well as drawing the taper. I usually try to put the point on the bar fairly quickly and then work the taper back from that point. You have to move a lot of material to create that point. If you wait too long in the heat, the bar might get too cold and it might start cracking on you and splitting at the very tip. As you can see, the tip is now cold, but there's still a fair amount of heat left in the main body of the hook that allows me to forge the rest of the taper. Also, having the point done first makes it easy to forge the taper to a specific length. I just keep working the taper back until I reach the measurement I need. For this hook, the small curl at the tip of the hook is facing away from the countersinks for the screw holes. Once again, I'll use the anvil to cool the tip slightly. It should be noted that I am keeping the main body of the hook away from the anvil. I'm lifting it slightly, otherwise I would be cooling that too. This is a nice little design for a wall hook. It looks good, it's very easy to make, and it'll cover any wall anchors you may need to install it. Once again, I'm using 3/8 round bar, but unlike the other two examples in this video, I'm going to start by drawing out the taper for the hook. This hook has to be forged off of a longer bar. It just wouldn't be practical to use a pair of tongs to handle the short little bar that you need to make this hook. To get consistent results with this kind of forging, you need to have a ruler set up on your anvil. It doesn't have to be anything fancy, just a scrap piece of metal with some marks filed into it. But the key is it has to be clamped to your anvil face so it's secure. This ruler is just marked off in inches, but I do have other rulers that are marked off with specific dimensions that I need for different forgings. With this ruler in place, it's really easy to check the length of the offset or the length of the final taper right as you're working. You don't have to stop to pick up a ruler or a pair of dividers. In this last heat, I'll clean up the taper and forge the hook. I found that I get a smoother transition into the beam if I start the small curl of the hook with the offset facing up. Once again, I'm cooling the tip by pressing it up against the anvil. When you're shaping this hook, you have to be careful not to curl the tip of the hook up past the shoulder of the offset. This offset is where you're going to be cross-peening the beam top of this hook, and it has to sit squarely on the corner of the anvil. As you can see, if I had curled this hook around any more, I wouldn't be able to forge the beam right at the offset where the start of the taper is for the hook. From the offset, I'm leaving about 1/2 inch of material for the beam. It really doesn't take that much to forge these. Now it's just a matter of using the cross peen to spread the material out. I usually start in the center and forge a well-defined groove. That divides the material that I'm going to need in half, and then I concentrate on each half, making sure that I have the same amount on each side of the beam.